At 10 wells, we gas production of 3,000 MSCF per day per well. So basically it's 3 million, right? 1 M is 1,000, so 2 M is million. Oil production is 8 barrels per 1 million of standard cubic foot. Dry heating value is 1,250 BTU per standard cubic foot. Henry Hub first month price is $8 something per million BTU. So this is the price per million BTU. So all this is given information, okay? Average month oil WTI price is that much, $60 per barrel. 5% shrinkage and pipeline losses. Do we have 5% loss in the pipeline? Is that what it's about? Who's next? Emily M. Billingsley. Hi Emily. Do we have 5% loss of gas in the pipeline when we sell it? Where is this 5% loss coming from? This is for the pipeline loss. See? When we sell the gas, we put the gas in before it reach the gas plant. We assume 5% shrinkage and pipeline loss. Where does this 5% come from? Can it be 4%? Do we have a leak in the pipe?
No.
Do we have a leak in the gas pipeline? Sometimes it's leak a little bit. Do we have 5% leak on the gas pipeline? Why do we put 5%? Can it be 4%? 3%? Can it be 4%, Danny?
Yes.
Yes, can it be 4%. We have solution for her, for Emily.
That shrinkage can also include fuel that's used in the plant. So all the compressors, the fire vessels, and all like that, that can all be rolled into shrinkage and pipeline loss. It is possible in gathering systems to have huge losses, I think 20%, where the gathering lines had a lot of leaks. And it's got to be a cooperative effort between the gas plant and the producer to identify those and reduce those. The 5% could be a contractual volume, but it's possible for those to be very high with very subtle leaks.
So 5%, it can be 4%, 6%, 10%. It's depending upon how we agree, okay, to another party. This is to account for any imperfect in gas compression system. When you compress a gas, you may lose a little bit of gas, and for any imperfection that happen during gas transportation, we account for that. Okay, any unforeseen leak or anything, we say okay, that's 5%. Gas contract info. Gas price is Henry Hub first month less or minus 0.15 million BTU. Okay, 0.15 per million BTU. Oil contract average month WTI less 2.5 per barrel. This is just a number from the contract. So basically, when you calculate it, they will say minus what? We will buy it at the price a little bit lower than Henry Hub or a little bit lower than WTI. How much? A little bit lower. So this is the contract value, okay? It's not like engineering value or something. So this comes from business offices. All this is a given information. Can we calculate how much revenue we will get if we sell this much gas that have this much oil? Can we? I may forget about it already, but the answer is on the next slide. And can you do this in the exam? Maybe it's too easy. So what do? I have, for gas revenue calculation, I have 10 wells, right? Each well have 3,000 standard cubic foot per day per well. So I multiply by 3,000. And I multiply by 0.95. 0.95 comes from 5% shrinkage or any imperfection in gas transportation. So that is where 0.95 comes from. multiplied by 1.25. 1.25 is MMBtu per 1,000 standard cubic foot, right? 1.25, that's my 1.25. Dry heating value. Okay. So we try to convert from flow rate to heating value. We convert from volume to BTU. So I multiply by 0.15. We, instead of use 1,250, I use 0.15 and I change the unit to MMBtu per MSCF. And then I have, you get it, right? So I put, instead of 1,000 something, I divided by 1,000, so I put one more M over here, and I do the unit change. I add one more M on the top and one more M on the bottom, so it's the same. So this is to convert the flow rate to BTU. And we have this part, 8.53 minus 0.15. Why do we need to have minus 0.15? Because that is as per the contract, right? It said they will buy it at the price a little bit less than the reference price. So the reference price is at $8 something, so they buy a little bit less 0.15 per 1,000 BTU. So that's why we have that. Okay, do the calculation, then we get that much revenue per day. So 1% of that is a lot. Our revenue, we have 10 barrels multiplied by 8 barrels per million standard cubic foot, and we have 3 million per barrel. So this is going to be amount of oil in barrel, right? And for each barrel, we sell at the price of reference point minus the value from the contract. So we get that much cash per day. Okay? Total monthly revenue, so multiply by 30. 1 month, assume 30 days. So on average, we have that much per month, $9 million. One of the reasons to show you the number is that, I want to show you that it is a lot. So that everything has to be in the gas contract. Who pay for what? Okay? And the next one is the percent of proceed contract. Mr. Bulla, you want to talk on the microphone?
A couple of comments first about gas contracts. First of all, the contract parts that you're seeing here are just sections that are taken out of a full contract. A full contract can be 25 or 30 pages long. It'll have technical terms and it'll have commercial terms. So some of the things we've been talking about are technical terms, like how much inerts can be in the gas, what is allowed and what isn't allowed. The commercial terms is what is the price that will be paid for a certain product and how will it be paid. There can be other commercial terms in there about the liabilities that we've been talking about, who pays for what and so on. So your friends over in the law school, they're looking at 20 pages of the contract, and you're the engineer, you're talking about 10 pages of it. You've got to get together and merge all that together. That becomes the total gas contract. The other thing was early on in the slides, it says the gas shall be commercially free of CO2, nitrogen, and other things like that. Does anybody know what commercially free means? Connor Black?
Yeah, Connor Black.
Where's Connor? Got it. What does it mean commercially free?
It's whatever standard that is used.
Okay, so I can do lots of things technically. I can spend any amount of money and I can get you whatever you want. Is it economic to do that? Is it considered reasonably commercial to do that? So there have to be boundaries on what is put in this contract. And commercially free is a term that's come through precedent by legal cases to say that you can spend, X% or this percent of money to clean up the gas, but it doesn't have to be cleaned up to the point that technically, as an engineer, I can raise my hand, I can do that. Commercially, as a businessman, you want to take it down to a point where it isn't disruptive to the plant, doesn't do anything harmful, but to the point where I don't have to spend everything technically feasible. So there can be a difference in the commercially reasonable terms and what is technically practical. Okay, percent of proceeds contract. When we have a gas plant involved, the gas plant, in essence, gets paid by taking a part of some of the revenue stream that you put in there as a producer. So they're going to measure the gas on the lease. They'll remove natural gas liquids from the stream. Remember, the schematic at first went to sales after liquids are extracted. It's not commercially reasonable to extract all of the liquids on the lease. We'd have to make that big investment everywhere we were selling gas to take out these products. So the contract's written so that the purchaser, the processor, picks up the gas at our lease sales point, takes it to the plant. At the plant, they will remove the natural gas liquids, the gasoline, butane, propane, and then they will sell the remaining gas or the residue gas, and they will sell the liquids. When they sell them, they're going to keep a certain percentage, and we talk about those percentages. They may also charge a compression fee, and it would be set as, say, 5 cents an MCF per gas that goes through the plant. That would be on top of the percent of revenue they're keeping. So there could be other charges, just even in a percent of proceeds contract. These are typical terms. These are not the only terms, but these are order of magnitude of what you could expect to see in a gas contract. So they will, processor generally keeps 10 to 20% of the residue gas revenue. And what does it mean to talk about the tailgate of a plant? Have you heard that term, tailgate of a plant? Kind of mean? Bohosu? How's the first name pronounced? Amin? Okay. Tailgate of a plant, what would that mean? Don't know? Okay. I drive a truck. And at the very back of the truck is a place where you can load things into it. And it's called tailgate. So if that analogy applies, what would be the tailgate of a gas plant? Okay, the back end, that would be on the front end, all the raw gas is coming in from the field. We do all the processing, and then it's sold at the tailgate of the plant. At the very end of the plant, after it's done all the processing, that's where the residue gas, what's left over, the residual, that's where it's sold. Okay? Make sense? What does city gate mean? Oh.
So the tailgate of a plant is where the residue gas is sold?
Right.
Okay, gotcha.
There's another term in gas sales called the city gate. What's that? Carson? Boyd? Carson? Ed? City gate. You heard that term? Okay, a while ago we had an example where gas was $8. That was taken a few years back from that example. The city gate is when the gas comes to the edge of Lubbock. That gas is then sold to a utility and goes into the distribution system. So that price is paid at the city gate. That's the last measuring point off the pipeline where the end customer is. When gas was at its highest, the city gate Chicago, they paid $15 an MCF for gas to get into Chicago. They're paying like $3 today for gas out of the field. It was really cold, they needed a lot, and the markets let them have it at 15 bucks. Okay, so where were we? On the revenue, 50% of our revenue from propane and butane is generally kept by the processor. That's And then 50% of the revenue from natural gas liquids or gasolines. Actually, sometimes at a gas plant, they'll pull a raw grade gasoline out of there. You wouldn't want to put it in your car. It would knock terribly. You could hear it coming. And it used to be the pumpers would go to the gas plant, work in the oil field, and they'd fill up their pickup trucks with that gasoline out of the gas plant. It's pretty rough on the engines. So they didn't get good mileage. Long before computers got in trucks and adjusted for the octane value. It's rough stuff, but it does have a market value. And then compression and treating fees are charged. They're not kept out of the stream, but those are charged based on the number of MCF processed. So the processor now is buying gas from everybody in here. He's got 75 customers or 78 customers. And Dr. Eckert and I are running the plant. We've got to take all your gas in. We've got to determine the volumes and the heat value of that gas coming in. Do all the treating, processing, use the fuel, and then tell you what you have left. So it has to be allocated. And the allocation is done on a volumetric basis, and it's done on a BTU basis. There will be gas allocated back based on MCF, and then there will be other charges made based on your allocation. Let's look at an example. We've got 3 producers in this case. Flow rate 1 is 1 million a day, and he's got a 1.1 BTU for SCF. That's pretty rich gas. Most gas contracts will specify around a million a day, and that's what would go to the city gate, is 1 million a day, or a BTU value of 1 million BTU. If it gets much hotter than that, you turn on the cook stove and you'll light off the ceiling if it gets too rich. Producer C has got a 500,000 a day going into the plant, and it's got a BTU value of 1 million BTU per MCF. It's good as it is. The producers, oh, that's producer B. Producer C has a flow rate of 1.5 million, but his BTU value is only 900. What would you think is in that gas stream? Yeah, it's got inerts in it. It could be CO2, it could be nitrogen. There's a field in New Mexico called the Maljamar field. It's San Andreas gas and oil. It has a standard, if you will, BTU content of about 1 million a day. There's a field just shallower than that that is got a nitrogen content of almost 50%. It's shallow gas, and so it really takes a big cut on the BTU value, but they all go to the same gas plant. And so that low BTU gas gets far less of its quantity going in there because it's using that higher gas. The plant's taking that higher BTU gas, mixing it with the lower, and getting a residue gas that meets pipeline quality. So in this case, when we allocate the gas, let's look at producer C. That's the producer that had the low BTU value. We've got 3 million a day going in there, and if we allocated just on volumes, he would get 1.5 million of 3 million. He'd get 50% of the gas stream. But because its BTU value is lower, we use the calculation where we're taking we're taking 1.5 million a day times its BTU value 900, and we're dividing it by the total. It's like a weighted average of all 3 streams going in. We've got 1,100 BTU, but only 0.5 million a day of that. We've got 1.5 million, but it's got a BTU value. Yeah, we've got 1 million, 1.5, yeah. Is that 1.5 or 1.5? Okay. 1.5 times 9, okay. So we add up those 3 streams, multiplied by 100, Now producer C only has 45.8% of the BTU values allocated back because it's got the poorer quality, even though he's got a higher flow rate. Make sense? And so then our processor, the gas plant, is going to keep a fraction of revenue based on the amount allocated to producer C, which was 45.8. This is a map of gas pipelines in the U.S. The blue lines are called interstate lines, like these. The red lines, where's an individual red line? Let's get out in California. They got a lot of red lines. No feeling in that finger. The red lines are interstate, intrastate, pardon me, INTRA state, means they only run within that state. Interstate go across state boundaries. So let's look right here. We talked about Henry Hub. Henry Hub is more than likely this accumulation, these dark blue spots right here, because it's just south of Lafayette, Louisiana. Waha, the other measuring point, is in North Pecos County in Texas. So that's that point right there. So when we had a price based on Waha, is West Texas, a price based on Henry Hub is down here in Louisiana. One of the advantages that you will find as you go to market with your gas is where is that gas ultimately being used. For example, look at this, going from Louisiana all the way up the East Coast into this dense population area in New England is an interstate pipeline. Along the way are gas storage fields or depleted gas fields that are being used like buffer zones where they go in and fill up, and the price that you put it in there in the summer may be low, and then as you take it out during the prime heating months, that price is raised and they take it out of these gas fields and run it into these markets. More markets are being developed down here for air conditioning in the south, but the concentration of lines going up here is huge. You look around here. These interstate lines, here goes one from Waha serving California. Another major market is up in northern New Mexico. These are coal bed methane fields. They go to California. And then folks up here in Washington State, they pay a lot of transportation charges to get back to big gas hubs. So that's all commercial, but where you go with your gas, where you're situated, is going to determine where you can make a good contract or a better contract to get a better price. You also don't have to actually move a molecule from, say, out of the Sprayberry field in West Texas to Louisiana across any of these systems. You got to go through a lot of lines to get down here. You don't actually have to move that molecule down here to get a Henry Hub price. You can get a Henry Hub price and sell your gas to somebody here, and they will ship gas from here to replace it. You do a swap. So the molecules, at some point they all have to account for being there, but a lot of people make a lot of money handling those swaps, getting it across there. So don't think that just because I'm going to drill this well up here, boy, I can't get Henry Hub price. I might be able to do it, but I'd have to do a swap to get molecules down there from somewhere else to allow me to get that price to take it to a West Coast market, or vice versa. Questions?
So this means you have gas pipeline everywhere, right? And after this class, you should get a job, okay? The job is everywhere. And you should be able to tell, hey, how much is the pressure drop if you move from this point to this point? Or say something very smart, okay, or look smart. Doesn't matter. So we have a lot of gas pipeline. Now let's talk about hydrate. And this is an overview, and we will talk more about it like in many more slides that we have. For hydrate, removal of water vapor from gas to lower than the dew point. If you have water vapor, it forms hydrate. And this is the limit, but you memorize number 7, okay, for South US. And we want to remove water to prevent corrosion. And there are several methods to do dehydration. We can do glycol contactor. You can do calcium chloride batch treating, molecular sieve. There are several methods. The most common one is glycol contactor. You will go to gas plant, and then we have more lecture on it. Gas plant is on April. Okay, gas plant is on April. Meet the gas contract requirement. We have to remove H2S and CO2. There are several methods, okay? Solid bed, chemical solvent, physical solvent, direct conversion to sulfur. What kind of method that we use to remove H2S and CO2? You will go to the gas plant, find out, and you tell me what do they use, okay? Gas processing, we have to do adsorption, refrigeration, cryogenic to remove CO2. You will see all this first at the gas plant before the lecture time. Okay. Hydrate formation from Wikipedia, it said gas hydrate is a hydrate consisting of water that is in which light hydrocarbon molecules are embedded, resembling dry, dirty ice. It looks like ice, but it's dirty. It has a structure of water, and in that structure there's something inside, light hydrocarbon. The part that is inside doesn't need to be the hydrocarbon, actually it can be like nitrogen. Okay. To measure conditions that promote hydrate: high gas pressure and low temperature. High pressure, low temperature. And one thing to memorize is gas at or below is water dew point. We will have with water, free water present. So if you have free water, we can have hydrate. Okay. Hydrate can form above 32 Fahrenheit. Okay, it can be 50 Fahrenheit. Alright? Even though it's not very cold, we can form hydrate if the pressure is high enough. Okay. Secondary conditions such as high gas velocity, agitation, and the formation of nucleation sites may also help to form hydrate. So let's say you have gas pipeline or some kind of pipeline, and we have some free water. We have high pressure gas on the top. High pressure gas on the top. Okay, you will form hydrate at the interface. Okay, you form hydrate at the interface. It doesn't block anything just yet. But if you flow very fast, there's some wave going on in here, hydrate start to accumulate. Okay? When you start to make wave and make it mix, so the contact point between liquid and gas. So if you have just nothing move, just high pressure, you have water and gas on the top, hydrate can form just at the interface, right? Hydrate need the water to form. Or you may have a little bit of vapor water on the top. Okay, you may form some hydrate, but when we flow, there's a mixing that promote more formation of the hydrate. You can cut the pipe within a matter of like half an hour or something. Quick, hydrate is like 15 minutes. Half an hour, you can plug the pipe. If you have wax form inside the pipeline, it takes like days, a week or something. It takes longer, but hydrate is a matter of like 15 minutes. It's quicker. You don't want hydrate to form in the pipe. It looks like this. It looks like ice, but you can have fire on top of it. Natural gas methane escaping from deep seabed formation can form methane granulate. Such deposit may form a future hydrocarbon energy source. Basically, I found that people think when we have hydrate on the subsea, on the seabed, that's maybe in the future as a new energy source. But the future is future, okay, not now. We have a lot of hydrate already. We don't want hydrate. We don't want hydrate anywhere. We don't want it in the line, the choke, in the valve, instrument, pipeline. When you take it out, it can be that big or bigger. It's like ice, right? It's dirty, and it's we can have that fire. How do we take hydrate out from the pipeline? Anyone know how to take hydrate out from the pipeline? Do we cut the pipe? We cut the pipe. Hey, hydrate form in the pipe. Hydrate is maybe easy to not easy. Easier to remove than some other thing. If you decrease the pressure, hydrate will form at high pressure, right? At low pressure, it's not stable to have hydrate. But it doesn't mean that when you reduce the pressure, hydrate will be just gone immediately. No, it's not like that. But you can remove the pressure and put some inhibitor in to remove hydrate if it gets stuck. Okay. Here's one more time. 3 more minutes. Pressure and temperature curve. See, this is temperature line. This is a pressure axis. This part is hydrate. If you have low temperature, high pressure, we form hydrate. Look at this ice temperature. So hydrate can form even though the temperature is above ice temperature. Okay. It doesn't mean that when we, let's say our pipeline, we have pipeline and the temperature drop, and we move into hydrate phase envelope. It doesn't mean that hydrate form immediately. It takes some time, okay? But if we stay inside the phase envelope just a little bit, it may be fine, okay? But we should not, okay? But it doesn't mean that it forms immediately. So this kind of phase envelope can be calculated, or you will use a chart, okay, to find, hey, at this temperature and pressure, we form hydrate. So if we have hydrate can form with methane, right? It can form with ethane, propane. So different component, different kind of gas have different temperature and pressure for hydrate to form. For example, at this temperature, if you have methane and high pressure and water, you don't form hydrate. But if you have ethane, you form hydrate. Okay, so it depends on what kind of gas. Hydrate phase envelope shape. Now is we will continue this later. Now it's 12:19. Tomorrow, who have not signed up for any time for 204? Everyone do it, right? Tomorrow is after the last day to add the class. So if you miss tomorrow, please start to count. And okay, today is the last day to add the class. If you want to help me more, I need some more people to help me count the number of slides in the file in the video file. You may not be interested in this, but you don't have much homework this week. So if you want to help me more doing the research in the lab, if you want to help me more on analyzing data, come see me. Oh, just go home. You can go now. Any volunteer to analyze